door. Either comes in stillages like that, sea containers like that one out there, or hook-lift bins where it gets dropped, just tipped on the ground and we've got to sort through it. So the first stage of our process is to sort into different material categories. So we sort into CRT televisions, which are those big box style televisions, flat screen TVs, LCDs, LCD monitors, printers, computers, what we call out of scope product, and there's one other one, I can't remember, you'll see it around here. I'll remember it soon. But basically we want to segregate into the different categories. The reason we do that is because we like to report back to the councils what they've actually recovered. The more data we've got, the better we can make decisions to actually try and change behaviour. So if we're getting a lot, like some councils, we see just send us just TVs, but they're not sending us anything else. And we can say, look, this is really great, but if you guys want to improve, there's a simple thing you can do here is just to say, hey, while you drop off your TV, you can also drop off these sorts of things as well. So there's a lot of misconceptions out there where people think, oh, this item is hazardous, this item is not really. It's better just to send it all in because we can recover everything, nearly. So once we've sorted it and segregated it, it'll go over the scales, it goes into our database. That computer up there was the one from here, tomorrow. So it'll go into the database, everything gets a label, so see on those cages there, they've all got a unique identifier, and that allows us to track it through our process, so we can tell any customer where their delivery is up to in terms of recycling. Just to give you an idea of how much we get in each day, that stockpile there represents about 4 days worth of material. And we have to physically pull through that material or that every day or quickly. Yeah. And we're only getting roughly 20% of electronics being thrown out that's sort of covered under the National Television Computer Recycling Scheme.
So
those numbers vary a bit. But
people's landfill bin or their recycle bin,
it won't come in.
You don't get it.
No. Unfortunately not. We're trying to work with a couple of MRF operators to pull it out when it comes across their sorting line. But they're high volume operations, it's really hard for them to actually do that, and usually it's covered in like nappies and stuff like that we don't really want to deal with, so we'd rather just give it to her or put it in an appropriate receptacle. It's one of the real challenges. It can be inconvenient to do the right thing, so we're trying to get as many collection points set up as we can so people don't have to drive sort of 20 k's to drop off a battery, which sort of defeats the purpose of recycling in the first place. We have to charge a fee to actually recycle our material because we've got 20 guys pulling it apart, and things like leaded glass and mercury lamps and batteries as well, they cost us to actually treat, so we send them to someone else that would charge us a fee to actually treat it, in the order of sort of like $10,000 for a container of leaded glass. So that's why we have to charge a fee. And anyway, Tamala Park were sending it to us recently, and until recently they've started using a company who's just exporting it over east for processing, and that's one thing that we're trying to stop. They've got their reasons for it. They've told us that it will come back to us soon. But we'll see. Yeah, we'll see. It puts some pressure on it. It'll be good.
Yeah, it's not a bad idea actually. Yeah.
We get the City of Stirling, we get most of the councils, most of the stuff recycled in WA or collected in WA will come to us. We get that much in. Once we've sorted it and segregated it, it'll go into our stock. It'll either go into that stockpile or straight to the plant stockpile. The reason we got 2 stockpiles is certain things we have to pull out before we can put it through the plant. And certain things are just way better to process manually. So I'll take you down to that process and sort of show you what we recover. Since people don't want to recycle their e-waste, on these hard drives, people pretty much got their life on the hard drive. So there's a lot of valuable material in the hard drive, but this sort of stuff if you're worried about your data, you can get a professional company to come and wipe it. Just putting in the recycling bin doesn't really get rid of it all. We use a company called, or a program called Blanco, and we can wipe up to 1,000 hard drives at a time. We charge about $7.50 to give you a certificate to say, here's your data's wiped. We have to charge just because it's a big risk if someone actually, they're like, hey, you got my data, someone got it, I give it to you. We need to spend the time and effort in actually controlling that process to make sure that it's working like it should do. So yes, once we've sorted and segregated, is to pre-sort it, what we call pre-sort or fully dismantle. So in that process, we start to separate things. So we've got like the laptop screen. So this one's an LED screen, so it doesn't actually need to be separated, but we just got a blanket rule to say that the laptop screens get pulled off and they can't run through the plant. This one might have one in it. They've got a little mercury back lamp usually inside the screen, and we've got to take that out before we put it through the plant, or you'll get mercury on your belts and everything else. You can't actually recover it. So there's a lot of things that we still have to do manually. Manual's still the best environmental outcome. To pull it all apart manually, you'll get the best recovery rate, but it means you'll be there for a very long time actually doing it. Because we're business and we're controlled by costs, we get set a budget per tonne on what we have to recycle it, and to do everything manually. Some things stack up, some things you can't do, and with everything getting smaller and smaller, you've got to use some sort of mechanical process to actually further recover it. But manual's a really good way to actually separate things. So we'll take out the mercury back lamps. That's the thing that I'm talking about. So there's little CCFL. There's a couple more here. So they're the little back lamps in your flat screen TVs, and they contain a bit of mercury and stuff in them. Try and minimise breakage, but because it's always getting tipped off, a lot of what we get is already broken. But we've done air sampling and mercury testing, and most of the mercury gets absorbed into the phosphor of the tube. We send that off to a company that crushes it up. They separate the glass from the phosphor, and they run the phosphor through a heating element, and that heats up the mercury. Once it gets over a certain temperature, mercury's got a low boiling point. It goes into vapour, and then they basically just use a distillery to distill it out of the vapour form, and then they can just tap off liquid mercury. So like people often want to know how to get it back to that end step. There's like an example of how that's done. Then the glass can be reused as a render additive or a construction aggregate. It would be good to get it back to glass recycling, which we used to have for CRT glass. But the thing with materials, it's called glass, but one glass used for one product is not the same as another glass used for another product. You can't make bottles out of this type of glass, I don't think. I know certain types of glass you can't. I don't know the exact chemistry of this glass, but it's one of the things to keep in mind when you're talking about recycling, to get it back to that high quality product. Because what we're after when we're recycling is we're after getting it back so that it can be substituted for a virgin material. We don't want to just make door stops that no one wants and say, oh, we recycled 1 million tonnes of plastic and produced 1 million door stops that are all housed in a warehouse somewhere, whilst they're still making door stops out of good material. You know, so we've got to do it the right way, and that means that we've got to turn or send the material to someone who has the capability to take it to that final step, or you keep working it through the process until you get there. So another example of what we pull out, these are the lead acid batteries in the UPS units, the uninterruptible power supplies. So we'll pull them out manually, because if they go through the plant, it leaks acid on the plant, you get a lot of lead and stuff mixing in with the other materials that you got. So this goes to, this is done in Australia as well. That's another great Australian initiative. The lead acid batteries that go over to Wagga Wagga in, I think it's Victoria, New South Wales. New South Wales. There's another one in Victoria. And they basically crush that up, and remove the lead, remove the sulfuric acid. They turn that into a salt, which can be used to make detergent. But they've got a large scale facility to get it to like a usable form. So what else do we pull out? Pull out batteries. So there's a battery sorting station there, but all those drums are full of different types of batteries. I was going to show you a quick video. I'll show you quickly if you gather around. So a lithium ion battery, when it's cut open, this is just one. I don't know if you saw the flames there, but if you can imagine that going in your compactor truck, it's going to cause a lot of issues. So yeah, this is the old CRT screens. When I talk about CRTs, these we still do manually. This used to be sort of 70% of the business. That's sort of what we were getting. By weight, they're quite heavy. In recent years, they've dropped off. It used to be about 80% of what we get. Now it's about 9%. So that's all still done fully manually. I don't have any tubes on the line so I can show you, but I might be able to just show you this old wooden one here. So this is a good example that people hold on to their electronics for some time, which is good. Yeah, it's good to see. Unfortunately, the older electronics are like a lot nastier than the newer days electronics, so you do have to be careful. But we'll basically recover the wood, send that to Hazelmere Wood Recycling Facility. Circuit boards we take out, send that to Mitsubishi. We process them through the plant first and remove the aluminium and ferrous components, and then the residual we send to Mitsubishi. But we've got this.
Japan? You send it to Japan?
Can't get to it.
You send it to Japan, to Mitsubishi in Japan?
Currently, yeah. There's a couple of ones we're trying to get going in Australia, but there's no one really that's doing it on a large scale here yet. There's a couple of companies that are looking to set up that we're keen to talk to. Nearstar, who we send our leaded glass to, they have the capability to do it, but they don't have an assay plant, so the commercial side of things they just need to work out. But yeah, we'll pull out this CRT screen here. I don't know if you can, basically you got a non-leaded piece of glass on the front and a leaded piece on the back, and it's welded together with a glass weld. We take that up those gravity rollers, we cut off that steel band, goes into the container there and magically separate. We separate that in there just to control the dust and everything, and we cut the leaded fraction using a diamond saw, and we just cut around the front of the glass. And then the leaded fraction goes off to Nearstar, where they put that through their smelting process. They can actually recover the lead out of the glass, and then they're left with like what they call a black sand, which goes to brighten cement, and they use that as a cement ingredient to help make their cement. So the whole piece of glass gets 100% recycled, and you're taking the lead out of it. There's a cost to do that, but that's the manual side of things. So some things we still do fully manually, and other things we'll run through the plant. A lot of people talk about torque with cars. The shredder's got 80,000 Newton meters of torque, basically a lot. Yeah, so it'll basically, well, you know those big steel cages up the back there? It'll pull one of those through in about just under a minute. So it just basically rips it all apart. That's the first stage of the process. Once it goes up the belt, it drops in there, gets shredded up, and comes out on this vibrating screen. So on the vibrating screen, the material comes out all sort of broken up. The way electronics is put together, It's with like screws and clips, so you apply force to it. That force has got to travel through the screw or the clip, and it usually breaks where it's been screwed together. So you get these nice big pieces of homogeneous material, which is easy for us to sort. So we've got this fines dust here. Now this is a product that we didn't know really what to do with. We just took it out at the first stage of the plant because we didn't want dust going all through the warehouse. It's more of a practical point of view rather than thinking from a recycling point of view. But I recently had it assayed, and it had 32 grams of gold per tonne, and one of these bags weighs about a tonne, so about an ounce of gold in the bag.
32 grams of gold raw material.
Yeah, and 500 grams of silver and about 90 grams of copper. So we were able to send that off to the smelter to further recover that.
That's all still against smelting in Japan, is it? Is that what
Yeah,
it's
this
called?
one is, but this only represents maybe 1% of the throughput of the plant. But yeah, that's currently still going in Japan. We are working with CSIRO to try and get a local solution. Just not quite there yet. Like, it's like literally they've got this amazing process which is no emissions. They capture all the emissions and they turn it into sulfuric acid, which they can use to make batteries and things like that. It's a really good setup that they got there. They're really fussy, but it's just a good example to show you that like everything has a value. You just got to find a solution for it, and it does help that there's an ounce of gold in the bag. But like you can use this sort of as an example for a heap of waste streams. You just got to find the need for the material that you've got. So material comes out here, it's broken up into pieces, it goes onto this belt, then people stand on the belt a bit further down. They'll pick off things like these electric motors, or these are transformers, which are copper and steel. So they'll get picked up by that mag belt. It'll drop onto that belt there, and they can pick that off. So this is a big permanent magnet. So as anything that's ferrous will get picked up on by this magnet. So not many people know that steel's the only metal that's magnetic at room temperature. I think there's a couple other compounds that you can get that are, but mainly steel's the main one. So the magnet will pull out all the steel, so you can sort of pick that up, and then it'll flick that off onto that belt. So that's where the steel, the majority of the steel exits the process at that point. We've got two pickers on the belts coming off the end there, and they're just picking off anything that's not steel, because sometimes you get plastic gets stuck underneath it, or it's not fully separated. It'll break them apart to a point, so that's why we've got pickers on there. So we've got those two pickers in there, and there's usually another one called retread bits. So anything that went on first pass, it hasn't been separated properly, they'll throw it off and it'll go back through. Roughly 20% of material has to go back through. But if there's not enough steel in it, then it'll keep going down the belt. So yeah, from there it'll go to the steel will leave the process here, majority of it. Then the pickers will pick off stuff like these electric motors. They'll pick them off the steel line. So if I throw that in, not all electric motors will get picked up by this. So we've got pickers on the belt, but if I throw that in, it'll get picked up by that magnet, and then the guys on that belt will pick them off. So this is a good example of a homogeneous output or product that we can send. We know what the limits of copper and steel and stuff is on what we call transformers or shredded armatures, and we can send that either through the back end of the plant. I don't like to do that because it's hell noisy and it damages our machinery. Or we send it to someone who's set up just to recycle these, and there's people around the world that actually just set up just to recycle these. Believe it or not, you can get a big, it's basically like a giant blender that they throw this in, and it disintegrates the steel from the copper. Then you can use magnets and electromagnetic separation, density separation, optical sorting to actually separate it. So we actually sell that as a product as is. You saw in that first slide in my younger days, all the copper that I pulled out, we did that manually. We figured out early on that we didn't have to do all that. We could sell it as it was, and someone else with the infrastructure can do a better job. Because to do everything under one roof is really inefficient and hard. You've got to get the balance right. You've got to do enough. But if we invested $7 billion in a circuit board refinery, and every other recycler in Australia did the same, you just have this massive duplication of effort, and it's a bit of a sort of waste of resources we can try to avoid. So then it keeps going through here, and we've got pickers, roughly 6 pickers on the line, just picking off focus material. So they'll be picking off things like the aluminium. So aluminium's not magnetic, so it doesn't actually get picked up by the magnet. This is what we call the first pass aluminium, so you can see there's still a bit of contamination in there. We would actually, on all of our aluminium, we actually run it back through the plant. Because the guys, we've got roughly 3 tonne an hour going through the plant. We've got guys picking it off as fast as they can. First pass, you don't always get the best outcome, but we can run just the aluminium back through. And it makes economic sense for us to do so, and we can get a really clean product out the end. Anything like that that's not properly separated, we can run through the back end of the plant and it will separate it further, basically. So they're picking off things like your circuit boards, your printed circuit boards, your copper wire, which you were asking me about before, that's over here. And just different sort of combinations of material. So you've got like the copper and aluminium. So you can't just put that in well, you can actually put it in a furnace, but you can't put it in a furnace and make a product out of that as is. You really want to separate the aluminium from the copper so you can get a high quality output and use it as a substitution for raw copper and raw aluminium. Hard drives is another thing that they pull off. So you've got neodymium rare earth magnets inside these hard drives. If you ever need any good fridge magnets, come and see us. You also got this circuit board, which is a very high gold content circuit board. So yeah, we can either further process this or just send it to people that just do hard drives, and there are people out there that do that. The copper wire is another good example. So with what happens to a lot of this stuff is it gets granulated. Once it's granulated, you can run it through a similar process like this and put it through a densimetric shaking table. So the copper separates from the plastic, but you've got a lot of other materials in these wires, and again, it's like we're reducing complexity from whole device to all these different types of material. This material's got to go through a similar process that's not just straightforward to actually get it back to a high quality material. Usually it'll go through some form of metallurgy to actually get it back so that it can be used. So currently these are going to Malaysia. There is a couple of recycling plants in Australia that are coming back online, but what we had previously is you had China that would take it all. They would offer a really good rate. They're more competitive than Australia, so all the plants that were here just shut down, basically. There's actually a plant just around the corner that's just opened up that we're going to start talking to at Allied Metals. But again, it's all driven by the economics. So as soon as you've got the government that says you have to do this because it's a better outcome, that sort of controls that decision for you. Because ultimately we are still a business and we've got to turn a profit to keep the doors open. So from there it'll go into this shredder. This is also what we use for data destruction, so if people want their hard drives destroyed, we can run them through here and they'll be crushed up. And that just basically separates anything that wasn't separated prior. So that uses impact to just break things apart. So if we had a bit of like a screw or a bit of steel attached to a big piece of plastic so that magnet couldn't lift it up, it'd keep coming through here and then it'd go into the hammer mill and that would separate the plastic from the steel. No, the plant only runs maybe 4 or 5 hours a day. So from there it'll go up onto this mag belt here, or the drum magnet there, so that'll pull out any remaining ferrous content. And then it goes over this eddy current separator. It's helpful, the guys have swept up the ground and chucked it all in the
Separator.
So this is not a good representation of what comes out here. The guys have swept up off the ground. This is sort of a better idea. So this is our what's coming out the back end of the eddy current. This is the plastic fraction. You can see there's a lot of contamination still. We recently got a grant to put in our optical sorter, and that'll arrive in 2 weeks' time, which I'm really excited about. And it's also, we've got a trommel coming with it as well, so we can take out any more of that fines material, which we've assayed again. We did a trial on that, and that contains a lot of the gold. So at present we've been sending this material to another recycler that has the infrastructure to further recycle it, but with this optical sorter we can actually get it back to a clean material stream. So when you're thinking about recycling plastics, it's the same as a lot of the other materials. That piece of plastic and that piece of plastic, you can't just melt them together because they might be different polymers. So the first stage for us is to remove contamination. So what we're trying to remove, and the sorter does it really well, is just like any of this sort of stuff. Then the next stage, and also the fine material. The next stage from there is we want to start sorting into different polymers. So we can sort ABS with ABS and high PS with high PS, and run that back through the process enough so it's really clean. At present we can get maybe $50 for the material per tonne. Once we get it clean, you can start getting sort of $1,000 a tonne. So that gives you the budget to process it over and over again to get it to that quality that you need it. So we're really looking forward to when that optical sorter comes in. We'll put some videos up on when that comes in. But anything that has a sheet of metal in it, conducts electricity, it can basically, it'll create a repulsion force. So you'll see things jumping off the belt. See how it gets sort of shot up in the air, and other things just flow through normally. All the material, it all goes back over there into the database, over the scales, so then we can report what our true recovery rate was. So we know how much has gone to landfill, how much has gone to supplier 1, supplier 2, and on and on. And then we're actually required under the Australian standard to go and verify their, like supplier 1's recovery rate. So we can amalgamate it all together and say, here's our true recovery rate. It's not quite as accurate as it probably should be, but it's a very difficult thing to do when you go and say, I sell this to a commodity trader. He doesn't want to tell me where it goes because he's afraid that I'll just sell it to who he sold it to.
Yeah.
So you've got all these commercial sensitivities to work through, which there are solutions coming about with like blockchain and all that sort of stuff. That'll start to come to the forefront to give traceability while still protecting privacy and commercial aspects of business. But they've still got a few challenges that they need to work out with that. We've probably got more regulations, just less enforcement, which is a big problem because once you've got the regulation there, if they don't enforce it, you've got operators that want to do the right thing, so they won't break the regulation. But then you've got the guys that don't care because they go, well, they're not checking. Let's just say we did it. So then you create this real two-tiered economy. We've got the other operation which does the asset recovery. which is equally as complex, but it's just trying to do a different thing. We're trying to preserve the functionality of devices, and data destruction is a big part of what we do there. But yeah, any questions?
Where do we, so you sell the stuff on through that, or have you got like a
Through like distributor channels. So Hybrid Hardware is one of the ones that we use. We've got a couple of local PC manufacturers that sell that direct. So they'll buy off us, they'll upgrade it, and then sell it to their customers. And then we've got sort of export channels where we'll sell like by the container load, say 1,000 PCs to a distributor who'll sell it to a heap of second-hand stores. Primarily, it's probably 50% done locally, 50% overseas. But we're seeing a trend move towards local, which is really good, because previously people just weren't interested in second-hand goods. But now you've got Vodafone and some of the big phone companies offering second-hand phone contracts, so you can save a lot of money by saying, oh, I'll have a refurbished phone as opposed to a new one. People at Apple are taking all their stuff back through their stores. Things are happening. There's a lot of issues, but that's like any industry. So we've just got to keep working through it.